All right, 7.2 notes. A probability model is a description of behavior that contains two parts: a list of all the outcomes and the probability for each outcome. Right? And a sample space is just the list of all the possible outcomes. The probability model includes the sample space, the list of all the possible outcomes, plus the probability of each outcome. So the sample space for flipping a coin, what are the possible outcomes when you flip a coin? No. What are the possible outcomes when you flip a coin? One coin. Head, tail. That's the sample space. Okay. If you're going to make that into a probability model, it would be head, or that has a half, and tail has a half. Sample space just lists them. Probability model also includes the chance of it happening. Okay, sample space for rolling a standard dice. 1, 2, 3, 4, 5, and 6. Turn it into a probability model by telling that each of them has a 1/6 chance of happening. Okay. An event is any collection of outcomes from some chance process. Every time you flip in a coin, that's an event. Every time you roll a dice, that's an event. Okay, we're going to roll 2 standard dice. The figure at the right shows the sample space of all the possible outcomes. First of all, how many different outcomes are there when you roll 2 dice? 36 is correct. And if you notice on the chart, along the diagonal, the sums are the same. So both of these are 11s, all of these ones are 9s, and so forth. On the diagonal, all the sums are the same. There's your 7. That was the one that had the most chance of happening. Alrighty. We're going to let event A be the sum of the dice is odd. So right here where it says P of A, that means probability of the sum being odd. Okay, that's what P of A means. Probability of A, or the probability of the sum being odd. How many of these sums are odd? Michael? 18 of them. So 18 out of 36. If you want to change that to 2%, you have 50%. You have an 18 out of 36 chance of rolling an odd number. Okay. The next event is going to be called B. The sum of the dice is prime. And C, the sum of the dice is greater than 9. We're going to find the probability of B and C. But I want to separate them out. First of all, what is the probability of B happening? What is the probability of the dice being a prime number? Remember, prime numbers are things that you can't divide, like by anything other than themselves and ones. So we're looking for 1s, 3s, 5s, 7s, and 11s. Can't divide it by anything other than itself and 1. So in these options, you're looking for 1s, 3s, 5s, 7s, and 11s.
So every odd number.
Except for 9.
14.
I got, no, 14's right. Yeah.
7.
Yep, 14 out of 36 chance of rolling a prime. Okay, P of C is being greater than 9. So we're not going to include 9. 6 out of 36. All right, so that's the probability of them individually, but the probability of them happening at the same time, probability of B and C happening. So what's the chance of picking a dice or rolling a dice that is prime and greater than 9?
20.
Less. It's prime and it's greater than 9. How many of those dice exist?
2.
Just 2. Only the 11s fit both categories. The probability of being prime and greater than 9 is only 2 out of 36. Questions there? Michael.
Is it 2 also prime?
Dang it. Yes. 2 is also prime, so our prime numbers are wrong, aren't they? We need to add the 2 in there, so it's really 15. Nice job, Michael. We're not talking about haircuts. We're talking about dice. Stay with me. No! Roll a dice. All right, here's your basic rules of probability. It has to be between 0 and 1. Between 0% and 100%. You know that. All the possible outcomes together must have a probability of 1. Means it has to add up to 100%. Every outcome must be accounted for. Each roll of the dice had a 1/6 chance of happening. You add them all together, you get 6 out of 6. 100%. Probability that an event does not occur is 1 minus the probability that it does. If the probability that Tidwell stays on topic is 25%, the probability that he doesn't stay on topic is 75%. If 2 events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. So like if the question was, what is the chance of rolling a 1 or a 3 on a regular dice? You can't roll them both at the same time, so you just add those 2 probabilities together. But if it was like the last question we did where it was prime and greater than 9, those do have things in common, so we couldn't just add the 15 and the 6. We had to actually recount it. And this last one is super easy. If everything is equally likely, you just take the number of outcomes divided by the total number of outcomes. All right, one more example, and then I'll give you your assignment. What is the probability of the sum not being prime? Do not go back and count things, because we already figured out the sum of it being prime. The prime was 15, right? So P of not prime. You did it really fast. Oh. Don't the registers tell you how much change to give? What is 36 minus 15?
487 or 89 cents. I saw you back 487 for change.
You're not going to keep your job very long.
I like my stats teacher, man. She does.
I would.
I didn't say that.
This is why I don't pay cash anywhere.
Yeah,
Usually it's on the losing side.
Favorite card.
But it tells you how much I
I never pay cash because I don't want to wait on them to give me my change back.
All right, any questions on the note?
Shut up, I'm counting.
One time I confused McDonald's burger.
Oh no!
I was confused with the confused.
Where did my,
Like one of the girls in my class worked with food, she messed up on my, I changed on the floor. Laura Duncan. Oh, well, she was made back changes it until it opened. She was like, actually never said that, and Laura just like left it and cried. I don't want to.
I remember McDonald's, my total was $13 and I had a 10 and a 20. The 10 wasn't enough. We gave him the 10 and the 20. And then the guy, the customer was really confused because I gave him a 10 and a 20, which was 13. My total was $14. We gave him the 20. And the 20. Confused.
Girl, Redder's better than TO, it's a chance, put this out all over it. You're looking at $30.
come on.
I'm kidding.
Okay.
This is great.
All right, I want you to open up your assignment for today, and I want to start you with the first one.
What did they write on it? It was, you know, it was-
Okay, so you need to make a sample space for tossing 4 coins. So that means you're listing all the possible ways to toss 4 coins. I want to show you an efficient way to make sure you're getting them all. Now, efficient, maybe not, but accurate, yes. Okay, I gotta zoom in really hard because it's a lot of writing. Okay, so this is called a tree diagram. 4 coins. First coin, you have 2 options, a head and a tail. Easy peasy. Okay. Then the second coin, you have 2 options from each of those. You can either get a head or a tail after the head, or you can get a head or a tail after the tail. Second coin, vertical. Third coin, same thing. You can get a head or a tail after each one of those. All right, I'm not going to do the whole tree, but you get the point here. And then for the fourth coin, it's the same thing. Another head or a tail, another head or a tail.
There's toast. I wish I did some text box, but.
And then you follow the path. So if I was following this path, my answer would be head, head, tail, head. Okay. Sorry, that's green. You can't like read that at all. Head, head, tail, head. All right, that's following the green path.
Yeah,
There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. There are 16 possibilities here. Not green. You can't see it. 16 possibilities. So if you do the whole tree, there'll be 16 branches along this row. Okay, where are you confused, Sybil?
Yeah, very top one.
Uh-huh.
The tails, put tails, and do it again, and you have tails, right?
Yep.
It's not really good to get much shot.
Because I stopped because it was 4 coins. So I got head, I got head, I got head, I got head. So there's head, 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 head.
It's gonna be the same on the bottom too, right?
The next one would be head, 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 tail. So this would be the very top one. Then it'd be head, 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 tail. That would be the next one.
Ah,
Oh.
head, head, and then tail head.
And then this one would be head, head, tail, tail. I'm just following my
Tail,
branches.
head.
So we got the 16 of them.
There will be 16 total.
You just follow the line, so like the top one, you go head, 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 head.
You could just list them. The tree diagram just helps make sure you get them all.
Head, head, and then goes to the tail part, is the next one down.
So after the very last one, why should I put a T at the end?
Because I did the first coin, I got a tail, and then I either got a head or a tail.
How about the little one? How about the little one?
Oh, the little ones. Right here.
It says head. Yeah.
head, tail.
This is a head, and that's a
So
tail.
I should have 4 letters